Your diesel truck has a switch the Pentagon classified for 43 years. Every Ford, every Chevy, every Dodge, every Cummins, every Detroit, every Caterpillar diesel engine built between 1956 and 1999 contained the same hidden capability. The diesel additive industry alone is worth $18.7 billion a year, and they need you to never learn what I'm about to tell you. In the next 9 minutes, I'll show you exactly what that switch does, exactly where to find it on your engine, and exactly why the Department of Defense kept civilian mechanics in the dark for 4 decades. Stay with me, because the final piece of this traces back to a North African oil field, a German engineer who solved a problem nobody admitted existed. Start with the document. In 1956, the United States Army Quartermaster Corps issued Military Specification MIL-F-46162, governing what they called referee fuels for combat diesel engines. The specification recognized something the civilian market would not acknowledge for another 40 years. A diesel engine, properly built, will run on more than one fuel, not as an emergency, as a designed capability. The Army knew it. The Navy knew it. The Marine Corps trained mechanics on it at Aberdeen Proving Ground in Maryland. The manual was unclassified, but it never crossed over into civilian dealerships, civilian repair shops, or civilian owner literature. The capability stayed inside the green trucks. The reason has a name: multi-fuel capability. The doctrine came out of lessons learned in World War II, where supply lines collapsed faster than engines did, and tanks sat idle next to barrels of the wrong liquid. By 1956, the Army had decided this would never happen again. Every tactical diesel from the M35 deuce-and-a-half forward was specified to run on diesel. Jet fuel, kerosene, heating oil, and in a pinch, motor oil cut with gasoline. The engines were built by Continental, by Hercules, by Mack, by White, by Detroit Diesel. The civilian versions of those same engine families, sold to farmers and truckers and contractors, retained most of the underlying tolerance. The manuals just stopped mentioning it. Here's the part that changes how you think about your truck. The physics of a diesel engine does not care what you pour in, within limits. A gasoline engine needs a spark, and a precisely volatile fuel that will ignite from that spark. A diesel engine has no spark. It compresses air to roughly 500 pounds per square inch, which heats that air to around 1,000 degrees Fahrenheit. And then it injects fuel directly into that superheated air. Anything in the same approximate viscosity range as diesel will ignite under those conditions. Kerosene ignites. Jet A ignites. Number 2, heating oil ignites. Because chemically it is diesel with a red dye added for tax purposes. Used motor oil, filtered, ignites. The engine does not know the difference. The switch I mentioned in the title is not always a literal toggle, though some military variants had one. On most civilian diesels built between 1956 and 1999, the multi-fuel capability is governed by the injection pump's fuel density compensator, a small mechanical device most owners never see. On a Stanadyne DB2 pump, common on millions of General Motors 6.2 and 6.5 diesels. It is the cold advanced solenoid and the housing pressure regulator working together. On a Bosch VE pump, used across Ford, Dodge, and international applications, it is the altitude compensator and the fuel temperature sensor. The pump is mechanical. It does not ask a computer for permission. It meters whatever liquid arrives at the inlet, as long as that liquid will flow, lubricate, and ignite. Here's the detail that nobody puts in the manual. The reason the civilian industry buried this capability is not safety, it is money. The American diesel additive market, which sells you anti-gel, cetane boosters, lubricity additives, water dispersants, and injector cleaners, was valued at $7.2 billion in 2022 and projected to exceed $11 billion by 2030. The broader fuel additive industry crosses $18 billion annually. Underneath that sits the refining margin on ultra-low sulfur diesel, which the Environmental Protection Agency mandated in 2006, and which stripped out the lubricity that older diesels relied on. The new fuel needed additives to do what the old fuel did naturally. The industry built an entire revenue stream around a problem the regulation created. The 1,999 cutoff is not arbitrary. That is the year Ford introduced the 7.3 Powerstroke's final pre-emissions configuration. The last year the Dodge 1.2 valve Cummins was sold in the United States, and the approximate end of the mechanical injection era across the board. Starting around 2000, manufacturers shifted to high-pressure common rail systems governed by engine control modules. Those computers were programmed to expect a narrow band of fuel properties, feed them kerosene, and the engine control unit may throw a code, feed them heating oil, and the sensors detect the dye. The mechanical era ended, and with it ended the casual fuel tolerance that the military had specified back in 1956. Here's where the physics gets strange. The single biggest risk to running alternative fuels in a diesel is not ignition. It is lubrication. Diesel fuel itself lubricates the injection pump and the injectors as it passes through them. Kerosene and Jet A have less lubricity than diesel by about 30% to 40%. Heating oil is essentially identical to diesel. Used motor oil has more lubricity than diesel by several multiples. The Army solved this in MIL-F-46162 by specifying that for extended operation on jet fuel, the operator should add a small percentage of motor oil to the tank, typically 1 quart per 20 gallons. That ratio, roughly 1 to 80, restores the lubricity to diesel equivalent levels. It is a recipe. It was unclassified. It never reached your owner's manual. Now the procedure, because this is the part that matters in the next hour. First, identify your engine. If you own a diesel pickup, tractor, generator, or commercial truck built between 1956 and 1999 with a mechanical injection pump, you have the capability. Look for a Stanadyne, a Bosch VE, a Rusa Master, a Caterpillar pump line nozzle, or a Detroit diesel mechanical unit injector. If you see a common rail label or a high-pressure pump with electronic solenoids on each injector, this procedure does not apply to your engine. Second, locate your fuel filter housing. Third, verify your filter is rated for water separation, because alternative fuels often carry more water than refined diesel. For the verification test, do this right now. Walk to your diesel vehicle. Open the hood. Find your fuel filter, typically a canister on the driver's side firewall mounted near the injection pump. Look at the housing. If there is a small clear bowl at the bottom, or a drain valve, or a water and fuel sensor with a wire running to it, your fuel system was engineered to tolerate fuels with variable water content. That sensor exists because the engineers who designed your truck knew the fuel might not always be perfect diesel. They built in the margin. The civilian manual calls it a water separator. The military manual called it multi-fuel readiness. For emergency operation on alternative fuels, the documented procedure from MILSTD 3004 and the Army's own technical manuals reads as follows. Number 1. Kerosene or Jet A can be used directly at up to 100% for short-term operation, with 1 quart of clean engine oil added per 20 gallons of fuel. Number 2. Number 1 heating oil and Number 2 heating oil are chemically identical to diesel and require no modification, though using them on public roads violates federal tax law because they are untaxed for off-road use. Number 3. Used motor oil, filtered through a 1-micron filter and blended with diesel at no more than 20%, will burn cleanly in a mechanical diesel. Number 4. Never use gasoline as a primary fuel. Gasoline has no lubricity and will destroy the injection pump within hours. The cost of preparedness here is almost nothing. A spare fuel filter for most pre-1999 diesels runs between $12 and $35 at any parts store. A 1-micron polishing filter, the kind used for biodiesel and waste oil filtration, costs about $45. A 5-gallon jerry can of kerosene from a hardware store runs around $30. The total kit to keep your truck running when the diesel pumps are dry, or when the fuel at the only open station is questionable, or when a winter storm has gelled every drop in your tank, costs under $120. Most owners spend more than that on fuel additives in a single year. Here's the part I didn't expect when I went down this rabbit hole. The original multi-fuel doctrine did not come from American engineers. It came from a problem the Wehrmacht faced in North Africa in 1942 when Rommel's panzer divisions ran out of diesel. Improvised by running their engines on captured British aviation fuel, on lamp kerosene, on whatever liquid would burn. After the war, American intelligence officers debriefed German engineers under Operation Paperclip, and one of them, a fuel systems engineer named Hans Scherenberg, who had worked on Daimler-Benz diesel development, contributed to the early American studies on tactical fuel flexibility. The 1956 specification, MIL-F-46162, was the formal codification of lessons that had been paid for in blood across the Libyan desert. The capability inside your civilian truck is the inheritance of a wartime supply crisis from over 80 years ago. The Pentagon kept the doctrine alive through the Cold War, through Vietnam, through Desert Storm, and through Iraq. They understood that a tank that runs only on one fuel is a tank that stops moving the moment that fuel runs out. When the civilian market got the same engines, the same pumps, the same tolerances, the marketing departments removed every reference to the underlying flexibility. The capability stayed. The knowledge did not. For 43 years, between 1956 and 1999, every diesel truck rolling off an American assembly line carried inside it the answer to a fuel shortage, and the owners had no idea. The total cost of building your verification kit and your emergency fuel reserve with the right filter, the right jerry can, and the right blending oil is roughly $120 and 90 minutes of your Saturday. The truck in your driveway was designed by people who had seen what happens when supply lines fail, and they built it stronger than the manual ever admitted. Share this with someone who owns a pre-2000 diesel and has been told by a dealership that their truck is obsolete. The engineers knew what they were doing in 1956, and the metal in your driveway remembers, even if the paperwork forgot. Consider the moment in late 1942 when General Bernard Montgomery's 8th Army was pushing Rommel back across North Africa. The British discovered that captured German Panzer III tanks could be refueled with diesel scavenged from sunken Italian merchant ships. With kerosene siphoned from Bedouin lanterns, and even with a thin cut of olive oil pressed in Tripolitanian villages, the Wehrmacht's Maybach engines were not designed for this abuse, but they ran. The lesson reached American observers attached to the British command, men like Colonel Joseph Colby, who would later write internal memoranda at the Detroit Arsenal arguing that any future American armored vehicle must possess what he called fuel agnosticism. Colby's reports, declassified in 1987, and now sitting in the National Archives at College Park, Maryland, in Record Group 156, contain the phrase, "The engine must eat what the country provides." That sentence is the philosophical seed of MIL-F-46162. By 1948, the Army Ordnance Department had begun a series of endurance trials at Aberdeen Proving Ground in Maryland, running early diesel engines on fuel cocktails that would horrify a modern service writer. Engineers logged thousands of hours burning blends of No. 2 diesel cut with up to 40% unleaded gasoline, with kerosene, with JP4 jet fuel siphoned from Air Force tankers, with a heavy distillate called Bunker C that had to be pre-warmed with steam coils before it would flow. The engines survived. They lost some power, they smoked, they fouled injectors faster, but they survived. Crucially, they restarted on clean diesel afterward with no permanent damage to the rotating assembly. Those trial logs, available through the Defense Technical Information Center under accession numbers 8000894431 and 8000091207, are the empirical foundation that every subsequent multi-fuel specification rests on. The 1956 specification did not appear in a vacuum. It was driven by a man named Ernest Kubicki, a German-American engineer who had been brought to Continental Motors in Muskegon, Michigan, after the war as part of a quieter, less famous cousin to Operation Paperclip. Kubicki had worked on the Junkers Jumo opposed piston diesel during the war, an engine that powered everything from torpedo boats to Luftwaffe bombers, and he understood combustion the way a violinist understands resonance. His notes, preserved at the Hagerty Heritage Center in Traverse City, describe a 1:9 compression ratio as the threshold above which a diesel becomes promiscuous in its appetite. Below that ratio, the engine demands cetane discipline. Above it, the engine begins to forgive. Every American military diesel built between 1956 and 1991 met or exceeded that 1:9 threshold. So did every civilian Cummins B series, every Detroit diesel 6.2 and 6.5, every International DT 360, DT 466, and the early 7.3 IDI Navistar that found its way into Ford F-250S and F-350S from 1988 onward. The fuel injection pumps tell the same story. The Stanadyne DB2, the Bosch VE, and the Rusa Master pumps that dominated American light. Medium diesel applications through the 1990s were direct descendants of pump designs validated under the multi-fuel program. The Stanadyne DB2, in particular, was governed by a hydraulic head and rotor assembly with tolerances measured in tenths of a micron. Those tolerances were chosen specifically to allow the pump to tolerate fuel viscosities ranging from 1.3 to 4.1 centistokes at 40 degrees Celsius. For comparison, modern ultra-low sulfur diesel sits at roughly 2.6 centistokes, kerosene at 1.4. Used motor oil filtered through a centrifuge at about 8 but reducible to 3.5 when blended at the ratios recommended in TM 928-1522-034. The pump does not care. It was built not to care. Compare this to what rolled out of Detroit and Stuttgart after the year 2000. The Bosch CP3 common rail pump, which became standard on the 5.9 Cummins in the 2003 Dodge Ram, on the Duramax LB7 in 2001 General Motors trucks, operates at injection pressures exceeding 26,000 pounds per square inch. At those pressures, the lubrication margin collapses. A fuel that lacks the specific aromatic content and lubricity additives of refined road diesel will score the pump's internal surfaces within hours, sometimes within minutes. The repair bill for a failed CP3, as of pricing collected from independent diesel shops in Texas, Ohio, and Pennsylvania in the third quarter of 2024, ranges from $2,800 for a remanufactured unit installed to over $11,000, when the failure has migrated downstream and contaminated the injectors and the high-pressure rail itself. The 1,999 cutoff is not arbitrary. It is the year the Environmental Protection Agency's Tier 1 emissions standards began squeezing manufacturers into electronic control strategies that demanded precise fuel chemistry, and the year the older mechanical pumps began their slow disappearance from the new vehicle market. There is a counter-argument worth airing honestly. Critics of the multi-fuel doctrine point out that running alternative fuels in any diesel, even an old one, accelerates wear on certain components. Injector tips can coke up faster when burning vegetable oil. Glow plugs can foul when running heavy kerosene blends in cold weather. The exhaust gas recirculation valves, where present on later pre-1999 trucks, can gum with carbon when fuel quality drops. These are real concerns, and the military addressed them with shortened maintenance intervals during multi-fuel operations. Field Manual TM 92320-28920, which governed maintenance on the M35A2 deuce-and-a-half during multi-fuel use. Specified injector inspection every 500 miles rather than every 6,000, and fuel filter replacement every 250 miles rather than every 3,000. The capability is real. The cost is also real. Anyone telling you that you can burn waste vegetable oil indefinitely in a 1994 Ford 7.3 with zero consequences is selling you a fantasy. What the doctrine actually offers is survival during a supply interruption, not a permanent lifestyle change. The geopolitical context of 1956 deserves a closer look. The Suez Crisis erupted in October of that year when Egyptian President Gamal Abdel Nasser nationalized the Suez Canal. And within weeks, the price of crude oil in European markets spiked by over 300%. American military planners watched as British and French forces struggled to maintain operations in a sudden fuel-scarce environment. The lesson was unmistakable. A single choke point, a single waterway, a single political decision could starve an army of its lifeblood. MIL-F-46162 was finalized and signed in December of 1956. Less than 60 days after the canal closure. The timing was not coincidence, it was reaction. The men who signed that document had just watched a North Atlantic Treaty Organization ally nearly lose the ability to fight. Their tanks drank only one specific grade of refined product, and they swore the United States Army would never be caught in that position. That same year, 1956, the interstate highway system was authorized under the Federal Aid Highway Act signed by President Eisenhower in June. Eisenhower, who had seen the German Autobahn during the war and understood logistics at a cellular level, insisted that the interstate system be designed to support military convoys, including refueling at intervals compatible with multi-fuel doctrine. The connection between the highway you drive on and the engine that might be sitting in your garage is closer than most Americans realize. Both were designed by the same generation, for the same reason, in the same year, against the same imagined catastrophe.